This is Unit 1, Video 6. In this video, we will talk about something called dimensional analysis. That's a fancy word for converting between different units. So in science, we use different types of units, and we have to convert from one to the other. These are the three rules for converting, and we'll do a bunch of examples to make sure we understand it. So what you do, rule number one, is you start with what you want to convert. Make sure to include the units. The units, remember, is what comes at the back of the number. Then you multiply by what's called a conversion factor, and this will be the relationship between the two units you want to convert. And this will be a fraction. So in other words, it'll look like this. You'll multiply by a fraction, and something will go up here and something will go down here. And then thirdly, you will write the conversion factor, the fraction, so that the unit you are converting from cancels out. So you'll see that, for example, if you begin with grams and you want to convert away from grams to, say, kilograms, you'll have to put grams on the bottom, so the two cancel out. We'll do a lot of problems with this, and it'll make much more sense. So here is an actual example. If you convert 2 hours into minutes, so really simple example, we know this is our conversion factor right here. Right in the middle here is our conversion factor. Now the conversion factor relates what you want to convert, which is hours, and what you want to convert to, which is minutes. So it actually relates hours to minutes. The conversion factor is there are 60 minutes in 1 hour. So the way you would set this up is, since you began with hours, that's what you want to start converting. You will put hours down at the bottom so the two cancel out. What you want to convert to, which is minutes, goes on top. And then you'll simply do the multiplication. You do 2 times 60 divided by 1, which is 120, and that is your answer. So pretty simple example. Let's go ahead and try some examples that are more for chemistry. So here we have a problem, example problem 8, and it says convert 5.5 miles into kilometers. We are given the conversion factor as 1 mile equals 1.6 kilometers. Rule number 1 says we write down what we want to convert with the units. So 5.5 miles is what we want to convert. So put 5.5, and then you can write out miles, or I'll put just the first two letters, which is mi. Rule number 2 says you multiply this by a conversion factor, which is a fraction. So go ahead and write multiply by a fraction. Now our conversion factor will actually go in the fraction, and the most important thing is whatever you begin with, which is miles, is what goes on the bottom of the conversion factor, so that they can't cancel out. This is the most important part. And on top goes the other thing, which is kilometers. Now what you then do is you put the numbers in based on the conversion, based on the units. So 1.0 went with the miles, so we'll put 1.0 down here. 1.6 went with the kilometers, we'll put 1.6 up here. And if you've got it set up right, then your miles should cancel out on top and on the bottom. The reason why this cancels out, remember, is that a number like 5.5 can be thought of as 5.5 over 1. So really this 5.5 is actually on top. Numbers on top cancel out with numbers on the bottom. That's why that works. If you plug this into your calculator, what you would have to do is 5.5 multiplied by 1.6 divided by 1.0, which turns out to be 5.5 times 1.6. If you do this in your calculator, your answer should be 8.8. Don't forget the units. Units here are kilometers. Whatever you didn't cancel out is what goes in your unit. Circle the entire answer to make sure I can see it, and that is how it's done. Let's go ahead and try another example. Let's convert 156 centimeters into meters. Now what we have to have is a conversion factor between centimeters and meters. So I have to know how many centimeters there are in a meter. Now from a previous lesson, a previous video, we said that 1 meter is actually equal to 100 centimeters. So meter stick is divided into 100 centimeters. This is your conversion factor that you'll be using. Okay? Begin with the number I give you along with the units. In this case, 156 centimeters. Don't forget the units. Multiply by a conversion factor. Most important thing is down at the bottom goes the same unit as you began with, centimeters, because you want those to cancel out. On top goes what you want to convert to, which is meters. And then we'll put the conversion factor in here. 1 meter is 100 centimeters. Make sure you just match the number. The 100 is with the centimeters, so you match those up. In the end, you do 156 times 1 divided by 100 and if you do this in a calculator, you should get 1.56 for your answer. The question is, what are the units? Well, centimeters canceled out. We are left with meters, so that will be your unit, meters. Circle the whole answer, and there it is. Go ahead and try this on your own. Pause the video, try problem 9 on your own. I'll give you the conversion factor here. Let's do an example that uses 2 conversion factors. This is going to be a little more challenging. This is a 2-step. Now the question says how many centimeters in 25 feet. And what I'm given is I'm given 2 conversion factors. One that takes me from feet to inches, and then another one that takes me from inches to centimeters. So this will be a 2-step problem. We started the same way. We begin with 25 feet. Go ahead and put 25 feet. And then in this case, because it's a 2-step problem, we'll actually multiply by 2 conversion factors, like so. Now, this conversion factor right here will take us from feet to inches. So we'll actually use this conversion factor in here, and this conversion factor will take us from inches to centimeters. So we'll use this conversion factor there. First, I want you to actually write in the units, not the numbers yet. So because we have feet that we're beginning with here, let's go ahead and put feet at the bottom. Now we're going to go from feet to inches. So we'll put IN for inches at the top because this is the conversion factor that goes in the first fraction. And then, because feet has canceled out, we're left with inches. So now, inches is the one that goes in the next conversion factor. Inches will go down here. Again, because they're on opposite sides. This is important. And then because we're using the second conversion factor, centimeters would go on top. Now it's set up correctly. The inches, in fact, cancel out, and you'll be left with centimeters, and that's what we want. We want how many centimeters in 25 feet. Now we can put in the numbers. The numbers then, from foot, it's 1 foot is 12 inches, so 1 goes with the foot, 12 goes with the inches. On the second one, it's 1 inch, 2.54, so 1 goes with the inch, 2.54 goes with the centimeters. And that is the setup. In this case, you'll multiply 25 by 12 divided by 1 times 2.54 divided by 1. So if you do that in your calculator, go ahead and see what we get. We should get 762. 762. Now, the question is, what are the units? And the units should be centimeters, so make sure you put centimeters in the back. And secondly, we now want to be able to use significant figures. Now for this, we go by the initial number. The initial number has 2 significant figures. And our final answer actually has to have 2 significant figures. It turns out your conversion factors are exact and they don't limit you. So since these are exact numbers, they won't limit you. So you will actually be limited by the number you begin with, which is 2 significant figures. So actually this gets rounded down to 760 centimeters. And that is your answer. Circle it and put it down. Go ahead and try practice problem 10 on your own. In this case, it's a 2-step, just like I did with you. So try this on your own. And let's do the toughest example, which is example 11. In this case, we're actually going to do what's called a 2-dimensional conversion. And a 2-dimensional conversion has a unit on top and a unit on the bottom. So 32 miles per gallon, 2 kilometers per liter. A good example of a 2-dimensional unit is density. It's something per something. Now, in this case, we're actually going to be using 2 conversion factors because we'll need to convert miles into kilometers, the top portion, and then the bottom portion, gallons to liters. So we'll actually have to use 2 steps. So it's a 2-dimensional, 2-step conversion problem. You begin it the same way. Go ahead and begin with the number that you're given, which is 32 miles per gallon, but write it in this way. 32 miles all over 1 gallon. So I want you to write it like this. Notice that I just converted it. Instead of doing the slash, I put it in a fraction form. And now I'm going to put 2 conversion factors side by side. My miles will convert first. So to convert from miles, which is on top here, I would put miles on the bottom. Now I'm going to go from miles to kilometers. So I'll put kilometers on top. And then I'll put in the numbers themselves. Now it's 1.0 miles, or 1 mile, to 1.6 kilometers. So those 2 go there. Now my miles have canceled out, so I can remove the miles, and my kilometers are left. That's what I want. Now for the second conversion factor, it's going to be a little tougher. The question is this: I've got to convert gallons into liters. Now gallons right now is on the bottom, so to cancel it out, I don't put it on the bottom, I put it on top. So notice they have to be on opposite sides. And then down here I put liters. My second conversion factor will go in here. So now, because gallons is on the bottom and on top, they get to cancel out, and that's the idea. So you put the numbers in, and here it says that 1 gallon is 3.78 liters. So this setup is a little tougher, but hopefully you can follow it and try it yourself. We'll do plenty of practice problems in class. What you should do then is 32 divided by 1 times 1.6 divided by 1 times 1 divided by 3.78. Go and do that into a calculator. And you should come out with an answer of 13.54. Now the first thing to ask is, what will be the units? Now the units will be whatever did not cancel out. Kilometers do not cancel out, liters do not cancel out. So my unit will actually be a two-dimensional unit, kilometers per liter. The second thing is to ask, how many significant figures should I have? Because I began with 2, I'll actually end with 2. Remember, my conversion factors don't limit me. So to round this down, round this to 2, you should get 14 kilometers per liter. Circle the answer, and there it is. A little tougher. Hopefully you can follow it. Go ahead and do an example problem yourself, and we'll practice a bunch of this in class.